Thesaurus ER and UML modeling, G to Z, implementation mechanism, an architectural mechanism used during the implementation process. They are refinements of design mechanisms, and specify the exact implementation of the mechanism. Next, for example, one particular implementation of the inter-process communication analysis mechanism as a shared memory design utilizing a particular operating system's shared memory function calls, concurrency conflicts, inappropriate simultaneous access to shared memory, may be prevented using semaphores, or using a latching mechanism, which in turn rest upon other implementation mechanisms. Next, implementation view. An architectural view describes the organization of the static software elements, code, data, and other accompanying artifacts on the development environment, in terms of packaging, layering and configuration management ownership, release strategy. In the unified process it is a view on the implementation model. Next, inheritance, the mechanism that makes generalization possible. A mechanism for creating full class description out of individual class segments. Interface, a collection of operations that are used to specify a service of a class or component. Next, logical view, an architectural view that describes the main classes in the design of the system, major business-related classes, and the classes define key behavioral and structural mechanisms, persistency, communications, fault tolerance, user interface. In the unified process, the logical view of the design model. Message, a specification of a communication between objects that conveys information with the expectation that activity will ensue. Next, method, a regular systematic way of accomplishing the detailed, logically ordered plans or procedures followed to accomplish a task or attain a goal. Or the implementation of an operation, the algorithm or procedure affects the results of an operation. Modularity, the logical and physical decomposition of things, for example, responsibilities, and software, into small, simple grouping, for example, requirements and classes, respectively, which increase the achievements of software engineering goals. Next, multiplicity, a specification of the range of allowable cardinalities that a set may assume. Navigability, the navigability property on a roll indicates it is possible to navigate from associating class to the target class using the association. Node, a runtime physical object that represents a computational resource, generally having at least a memory and often processing capability as well. Runtime objects and components may reside on nodes. Next, object, an entity with a well-defined boundary and identity that encapsulates resource, state and behavior. State is represented by attributes and relationships, to represent behavior by operations and methods. An object is an instance of a class. Operation, a service that can be requested from an object to effect behavior. Next, package, a grouping of modeling elements. Pattern, a scheme for describing design fragments or collections of class templates so that they can be configured and reused. Polymorphism, polymorphism is the ability to define a single interface with multiple implementations. Next, processes, any thread of control that can logically execute concurrently with other processes, or a set of partially ordered steps intended to reach a goal. In software engineering, the goal is to build a software product or to enhance an existing one. In process engineering, the goal is to develop or enhance a process model, corresponds to a business use case in business engineering. Next, process view, an architectural view describes the concurrent aspects of the system, tasks, processes, and their interactions. Property, a named value denoting characteristic of an element. Realization, a semantics relationship between classifiers, in which one classifier specifies a contract that another classifier guarantees to carry out. Next, responsibility, a contract or obligation of a type or class. Scenario, the behavior of entity participating in a particular context. Next, sequence diagram, a diagram that describes a pattern of interaction among objects, arranged in chronological order. It shows the objects participating in their interaction by their lifelines and the messages that they send to each other. Next, state, a condition or situation during the life of an object when it satisfies some condition, performs an activity, or an event. State chart, a state diagram shows a state machine, that is, a behavior that specifies the sequences of states that an object goes through during its life in response to events, together with its responses and actions. Next, stereotype, a meta-classification of an element. Stereotypes have semantic implications, which can be specified for every specific stereotype value. Next, subsystem, a model element, which has the semantics of a package, such that it can contain other model elements, and a class, such that it has behavior. Classes or other subsystems it provide the behavior of the subsystem. A subsystem realizes one or more interfaces, which define the behavior it can perform. Next, thread, an independent computation executing within an execution environment and address space defined by an enclosing operating system process. Transition, a transition is a change from an originating state to a successor state as a result of some stimulus. Next, use case. A use case defines a set of instances, where each instance is a sequence of actions system performs that yields an observable result of value to a particular actor. A use case class contains all main alternate flows of events related to producing the observable result of value. Technically, use case is a class whose instances are scenarios. Next, use case model, a model of what the system is supposed to do in the system environment. Use case realization. A use case realization describes how a particular use case is realized within the design's model, in terms of collaborating objects. Next, use case view. An architectural view describes how critical use cases are performed in the system, while focusing mostly on architecturally significant components, objects, tasks, nodes. In the United process, it is a view of the use case model. Next, utility class, a class that contains a collection of free sub-programs. Visibility, how a name can be seen and used by others. Next, end of Thesaurus ER and UML modeling, H to Z. End of Thesaurus of UML modeling. End of e-monograph. Thanks.